again, people, in another episode of I'm a Physics Student, Save Me. We have today another problem about friction, like the previous videos I made before, but this time it's a friction on an inclined plane, or like over a ramp. Again, as a definition, friction force always opposes motion. So if we imagine this rabbit is you being inspired and motivated in life and moving to the right direction, and then your stepfather or your stepmom or your a-hole of a roommate, they are the force that opposes your motivation and the force moving to the right direction. So it moves you this way. So that's the friction. So usually friction really opposes the motion of this rabbit that's trying to move forward. So now, just to start with a question, we'll use Newton's second law, which is force equal mass multiplied by acceleration. On an inclined plane, we have a 50 kilogram mass on an incline that makes a 30-degree angle. The coefficient of friction is in decimals, 0.2. We need to find the acceleration. So we draw the free body diagram to make things clearer for us. Okay, and so we draw the ramp, and over there's the 50 kilogram object or a box, and we have the incline here 30 degrees. We will see the forces that are affecting this box. So it would be the mass, and it will be that makes it move to this direction, and as well the force of gravity, which is mg. But to make it easier for us to solve it, we will break this mg into two other forces in this direction and this direction, so more perpendicular and horizontal on the ramp. So we will consider to be like that instead of like this. So we will cancel this mg out, and we will make it mg cos theta and mg sine theta with problems with an incline. So what makes us choose cos or sine? In other videos on YouTube that deals with the same problem, they don't tell you why exactly cos or sine. They tell you, like, briefly, you use trigonometry, which is right, you use it, but I will go through a bit of an explanation. So when we are looking at this box that it's moving to this direction, we will consider this angle here, and this angle is facing this side of a triangle, so we will consider it's like a triangle, right angle triangle, and it's facing this one, which is the x-axis. This is the y-axis, this is the x-axis. So usually when we solve for sine in trigonometry problem, sine usually equal opposite over hypotenuse, and cos equals adjacent over hypotenuse. So as we are dealing with the side of opposite of the angle, and it's x-axis, so we know the x-axis, or whatever goes into this direction, if we look at it, x-axis is sine, and the other one will be cos, because the y-axis, if we see them like that, it's adjacent to the angle, so it's this side of the triangle. So as we solve it like here, we will use sine instead of cos. So it will be mg sine theta, and it will be mg cos theta. For more information about it, yeah, go through trigonometry, I recommend, but that's like a brief explanation. So now we need to find the normal force as well, because usually when we solve for friction, we need to use the formula for friction and the Newton's law. So to solve the formula of friction, we need to have the coefficient and the normal force. And to find the normal force, we will just look at the Newton's third law, which is the force of gravity, this one, the mg, is equal to Fn when an object is over like a surface. So it will be mg cos will be equal to fn to the other direction, because this is fg here. So usually fn equal fg, especially if the object is over a plane. And that's because the object doesn't, for example, float in the air or just sink into the ramp, and it stays there. So that means there's something here that it's 0. So it's in opposite direction but equal in value. So we will see here, we will start solving through Newton's second law, because we have now all the values we need. So it will be the force, like the previous problems about friction, but even without an incline, we use the same problem here. So we use the net force to find the acceleration. So the net force in the x-axis here, because really the forces are only affecting the object in a x-axis, because it's either like moving to this direction or this direction. It's not moving up and down. It's not, if you look at it, it's moving right here. It's not getting lifted off the ground or off the plane, the ramp. Okay, so this one here, we will just added mg sine theta, so that's the force of it sliding down. And there is the other opposing force, the friction. Remember the sweet rabbit story. So the friction to the other side is mg cos theta mu. And we need to explain this a little bit why it's like that, because we are discussing the force of friction. And the force of friction, to find it, because we don't have still the value of it, so we will add it mu from the formula of friction, mu multiplied by Fn. Fn, we find it where it was Fn. This one, remember, because we said it's equal to the Fg, Fg equal Fn, so we find it already here. So we will add it, and we will add the mu with it, so we find the value of friction. We have mu now, and we have Fn. And all will be over the mass according to Newton's second law. So now we have, we added together the mg, so we added mg to mg with a calculation, and we will end up with mg sine theta minus cos theta mu over m. We cancel the m together with a calculation, and then we will end up just only with the gravity, sine theta minus cos theta mu. We just added the values in 9.8, it's the constant of the gravity, memorize that already, and sine theta is half, which is also trigonometry. There's a table about like sine theta and cos theta, their values, and you can either like memorize that table or just use a calculator already. So half minus 0.8, which is cos theta, multiplied by coefficient of friction, the mu, which we have in the question already, 0.2. It was mentioned in the question in the first page. And just by a simple calculation, we calculate that first, and then multiplied by 9.8, we'll end up with this value here, meter per square, per second square, the acceleration. That's it. Now you know how to solve friction over an inclined plane. And this one actually is with friction. There are some problems that is frictionless. We will discuss in another problem or another video. Thank you very much.